Have you ever wondered how major tech companies manage their complex AI systems, ensuring they run smoothly, securely, and within budget? Today, we're diving deep into the world of enterprise-grade AI tool orchestration. This isn't just about calling a few APIs, it's about building robust, resilient systems that can handle millions of requests. By the end of this lesson, you will truly understand the necessity of advanced tool orchestration. We'll explore why simple script automation just isn't enough in a production environment. You'll also learn to identify key architectural components that form the backbone of these sophisticated systems. From intelligent routing to parallel execution engines, these are the building blocks that allow systems to scale reliably. Furthermore, you'll grasp principles of security, failure recovery, and cost optimization. These elements are absolutely critical for any system operating at scale, preventing budget overruns, data breaches, and service disruptions. Finally, our goal is to empower you to apply these concepts to build production-ready AI agents. This isn't theoretical. It's about giving you the practical insights to design and implement AI systems that stand up to real-world demands. Let's begin by understanding the sheer scale and complexity that necessitates such advanced orchestration. Imagine Netflix's recommendation engine processing hundreds of millions of user interactions every single day, or Google Search handling billions of queries. These aren't just simple programs, they are incredibly sophisticated machines. The truth is, enterprise systems rely on sophisticated orchestration to manage this immense scale and complexity. It's not just about getting a task done, but doing it reliably, efficiently, and securely every single time. This reality means that millions of AI requests demand robust patterns for execution, validation, and recovery. Without these patterns, systems would quickly buckle under pressure, leading to outages and poor user experiences. We'll see that key components include parallel execution and security at every step. Think about it. You can't have a single tool running everything sequentially when you have millions of simultaneous users. And security, of course, is non-negotiable. The fascinating part is that even though we're talking about massive systems, small-scale agents use the same architectural patterns. The principles remain constant whether you're building for a few users or a global audience. So how do we actually construct these patterns? Let's break down the core architecture. To truly understand orchestration, think of it like conducting a symphony. Each tool is an instrument, and your system is the conductor, ensuring every part plays perfectly in harmony. At the heart of it all is the tool chain manager. This component is your traffic controller, routing requests through various stages like validation and execution. It makes sure no tool runs without proper authorization, maintaining order and security. Next, we have the parallel execution engine. This is where the magic of concurrency happens. It manages multiple tool calls simultaneously, but critically, it does so with resource limits. Just like Stripe handles thousands of payments, this engine ensures safe concurrent operations without overwhelming your system. Then there's the security validator. Every single interaction, every input, every output from a tool passes through rigorous security checks. This isn't just a suggestion, it's a necessity to prevent exploitation and ensure your agent never returns malicious content. Finally, the cost tracker is indispensable. It monitors every API call, every bit of compute usage. In production, granular cost visibility is crucial to prevent budget overruns and make informed decisions about resource allocation. Now that we know the components, let's trace how data actually flows through this intricate system. With these core components in place, let's visualize the journey a research query takes through our sophisticated orchestration system. It's a precise dance of data and logic. First, requests flow through selection, execution, and validation stages. A research query arrives, and the AI determines exactly which tools are needed and in what sequence. Then, the system kicks off parallel orchestration, executing multiple tools simultaneously within predefined resource constraints. After execution, each tool's output enters a validation pipeline for security and quality checks. Once validated, outputs are synthesized, monitored, and logged. The individual tool results combine into a final comprehensive research report. Simultaneously, Metrics, costs, and security events are logged for continuous monitoring and analysis. Crucially, our system doesn't just track simple success or failure, it tracks execution, security, resource, and cost states simultaneously. This means we have a real-time, multi-dimensional view of our system's health and performance. This multi-dimensional state management is crucial for scale, mirroring how services like AWS manage millions of function executions. Knowing the state of everything allows for intelligent decision-making and rapid response to issues. But what happens when things inevitably go wrong? Or when costs spiral out of control? That's where our next set of patterns come in. In the real world, systems fail, and security threats are constant. Building an enterprise agent means preparing for these realities, not just hoping they don't happen. Our approach includes defense in-depth security with input validation, output filtering, and resource isolation. Every parameter is sanitized, results are screened for sensitive data, and tools run in isolated environments. This multi-layered defense is far beyond simple security checks. When tools inevitably fail, our system employs robust failure recovery patterns like circuit breakers, retries with exponential backoff, and graceful degradation. If a tool is consistently failing, a circuit breaker temporarily disables it, preventing cascading failures. Temporary glitches get retries. And if all else fails, the system can still provide partial, useful results. Beyond resilience, cost optimization is paramount with granular tracking and intelligent routing. We track cost per request, per tool, per user. This allows us to make smart decisions, maybe trying a cheaper tool first, only escalating to more expensive options if absolutely necessary. By implementing these patterns, you'll be able to build resilient, secure, and cost-efficient AI systems. This isn't just an academic exercise. It's the foundation for production AI systems that handle real-world complexity with enterprise-grade reliability and compliance. Now, consider this. What is one key difference between simple tool calling and enterprise-grade tool orchestration? And why is it essential?